we're going to be finishing off the last couple of slides here for Chapter 10, and we had left off where we were looking at some of the considerations we have to keep in mind when we're looking at standardizing for different aspects of our intelligence tests. So just quick hopping back here, we had looked at the fact that we develop norms. So out of all of the questions that we choose, and choosing questions can tie into this as well, but you want to look at the questions you have, the scores you collect from those questions, and then our patterns of what those scores look like within a given population. And so these standards behind the scenes in what we would expect in a normal population gives us something against which to compare some new individual score. So we would look at a distribution like this one here. So this is just something we might expect. And as with most of our tests that are going to print out a single IQ score, they're designed to have that average at 100. And then the scores are standardized so that we get an approximately normal curve. Usually I think they'll probably go for a properly normal curve, but what we care about is the fact that we have predictable percentages of individuals that would fall between certain ranges. So if we get an individual who has a score of 110, then we could say that they score below this percentage of the population and they score above this percentage of the population. So our standardization gives us something to compare against. It allows us to put that individual score into context regarding the population that this test was designed for. We then also spent some time talking about controlled procedures, so things like delivering the test the same way, having the same environment while the test is delivered. The types of instructions that are given should be standardized as well, where basically we're going to do everything in our power to try and control for potential confounding variables. We want to make sure that any variation in individual scores is due to our measure of intelligence and not due to something like being given a leading instruction or a misleading instruction, or because some people had annoying sounds in the background and some people didn't. It should all be standardized and equivalent across the board so that the differences we see come from the underlying intelligence of those individuals as measured by this specific test. All right, so that was all about our standardization and considerations. And of course, we can think of some other aspects that are important to keep in mind when designing these different tests, but those are the important ones for the levels of this course. Our next little bit here is looking at a couple of ways that we might look at existing intelligence tests or modify intelligence tests to account for some of the biases that we've been hinting at in the background. And I suppose by hinting at, I mean explicitly talking about repeatedly up until this point. But we've stressed a lot that there's a bias in using sort of North American or Western culture designed IQ tests in other places in the world. And we tied this all the way back to the beginnings of the very earliest of our intelligence tests. And even before that, with Galton and his ideas about looking at even perception and sensation type abilities and having sort of racist starting points that led to racist tests, that led to racist interpretations, and so on. But some of the things that we can do if we want to account for that and compensate for that, to find a way to actually be able to get an accurate, or as accurate as possible, comparison between cultures, knowing those biases exist. So one of them would be to do something like our Raven matrices do, which is where we can use problems and questions that aren't tied to the knowledge base of any given culture. So instead of relying on solving math problems, which might be set up in a way that favors North American educations, maybe we just look for general pattern recognition. So we saw that, as I said, with our Raven matrices, where they have a bunch of shapes and a bunch of patterns, and you have to decide what continues or finishes a pattern. And so this typically gets us that ability to analyze different stimulus patterns and relationships between shapes. We could, of course, sort of squint at stuff and say, well, maybe there are some biases in shape learning in different schools in different countries, but overall that should help mitigate at least, say, language differences or sort of larger scale, more complicated learning and reasoning skills. But one approach that you could use. Another alternative is actually to end up creating measures that are tailored to the kinds of knowledge that are valued in a given culture. So, if we've said that our North American tests are designed for North Americans, or maybe we have a Canada specific versus an American specific, well, let's go to another culture and say, okay, what ways could we modify these questions where it's getting at this information and the solutions would match to the ways of thinking that are prized and therefore probably taught in this group? Can we find representative questions that will get at similar types of skills, but just with different baselines so that we don't have that bias of education or things that are over or underweighted in terms of importance? We're designing a new test or modifying an existing test to match those values in that culture. One of the downsides of this one is going to be that, yes, it's now tailored to this culture, but has that affected our ability to compare between cultures? So yes, it could give us an IQ score, but are the two scores comparable because they're now two different tests? We might have a little bit more confidence comparing Raven Matrix scores across multiple cultures, but again, restrictions or limitations being it's good for, say, stimulus pattern recognition, but it might not be good for other types of problem solving abilities. So we might have to decide which of these is most important for us and maybe use a little bit of both to try and make some of those comparisons. But this is one of the reasons why typically in our textbooks, we mention that there are some differences, but we stress that they're not as clean cut, they're not as obvious as what some sources might present them as. So the tests themselves can cause bias, and other extraneous variables can cause bias too. So just, again, stuff to keep in mind. Our next little section here is looking at patterns of intelligence across time. And it's sort of an interesting discussion to look at intelligence and development of intelligence. One of the issues we run into here, so this is one of our WACE editions, and the scores of people from 16 all the way up to 89. And so with these scores, we're saying, okay, we see stability during adulthood or mostly adulthood, and then a gradual decline into old age. But this doesn't actually show us anything below 16. So for children, and that's because instead of the WACE, that would be using the WASC. And depending on what our measures are for children, if we look at, say, the starting point, early IQs were affected by the age of the individual, where you wouldn't necessarily be able to compare an 11-year-old to a 12-year-old other than are they performing at the level expected of their age. So we wouldn't get to see, say, this slow increase into sort of full maturation of adulthood here. So from this, we could say, yeah, we kind of see an increase into proper adulthood. And we usually say that as sort of our cutoff for adulthood, because if you look at studies of development and when our brains are finally done developing, it's usually in this 20 to 24 window that we would say that our prefrontal cortexes, those sort of last structures to develop, are going to finalize and stabilize. So before this point, we're still having stuff changing in those areas. But yeah, so we see that gradual increase until here and a little bit later, and then we continue up and then drop down without error bars. I'd say this is almost flat. I wouldn't want to make too many dramatic statements here. But this shows us that, yeah, we're not going to see a decline until we get older, and then we have that natural decline with age. But I point this out specifically because if we were looking at children's scores on an equivalent test on specifically the WACE, they wouldn't have the ability to solve a vast majority of those questions. So it's kind of hard to have a quantifying sort of graph to show that. One more consideration here that I'd recommend looking at is the fact that this axis with our IQ scores, it doesn't go down to 0. So it's not like we're seeing that people's IQs go from about 100 down to like very close to 0. We're actually just seeing that change from, say, 105 to 75 or so. So still a decline and still an obvious decline. However, axes can be misleading. We should also note, so this gradual decline at the end is probably because as we get older, we lose a lot of flexibility and our ability to sort of process things quickly simply because of our age. So we could, I think we mentioned this before in the class, where we talked about our fluid intelligence tends to decline faster with age, whereas our crystallized intelligence stays stable a lot longer, simply because our crystallized intelligence is something where, as we gain new experience, we're building up more knowledge. But the fluid experience would definitely tie into our ability to think and process in flexible ways. So as our processing speed slows down with age, associated intelligence-related tasks would slow down as well. We should continue saying that if we break it down even further, depending on our models, we have lots of different aspects of intelligence to look at. Some of these age-related declines end up being a lot more evident in some domains than others. So especially if we got into things like kinesthetic type intelligences, body coordination tends to decline very quickly with age. And that's a lot to do with the fact that our cells aren't as efficient at replacing other cells. For skills that tend to remain fairly consistent, things like vocabulary, that general information or crystallized intelligence related stuff, and even verbal reasoning, those seem to stay fairly stable all the way up to age 70. But as soon as we have a time component, or as soon as we get into flexible abstract thinking or learning new tasks, those tend to decline a lot earlier on. So it's very interesting to see how these different types of intelligence seem to be affected in different ways. All right. Our next bunch of slides here are all to do with sex differences in cognitive abilities. And we have the same considerations in the background that we're seeing differences between groups. So this is like, on average, we see that females perform better than males on this type of task. But there's a lot of overlap between the groups. I always like to give that caveat. And this can again be biased on certain tasks. And one of the examples I love to include for we found a clear bias in one field and then realized there was something that might be directly involved. So some of the earlier spatial orientation tasks, which could be lumped in with memory, especially in spatial tasks and things like that. But if you look at what types of cues people rely on in their environments, there's been a lot of cool research looking at the slope of the floor. Because we care about breaking down things into sort of geometric or like physical feature cues, but you don't need to know that part. All we care about is slope, and slope is neither geometry or feature. It's just its own thing. But in studies using slope as something that tells you where you might find a location that you're supposed to find, males are far more successful on these tasks than females. So males can reliably rely on the slope of the floor to find the correct corner in a room. Whereas females are very unlikely to find the correct corner with slope alone. They need other cues present. And so people were like, oh my gosh, so males are just really much better at this cue. But there was some questions about, well, what could explain that? And they started pointing to women wearing high-heeled shoes. And so having different heights of shoes means that you are less sensitive to the slope of the floor because you're used to compensating for different heights of footwear. And so that was their one explanation for why we saw such a large difference in average ability. So I just point that out because for some of these, there might be something to do with experience or social raising environments or something like that that might play a role here as well. And they're listed nice and clean on the slides here, but I actually like this figure to talk through some of the tasks that we see sort of performing better, or one sex performing better than the other. So we see that women perform better on perceptual speed tasks. So this would be something like a matching to sample task. So we show you the blue one, that is our sample, and of these options, which matches this sample. So if you have a time constraint, or if they look at, say, how quickly you can select the correct answer, women's scores will be better than men's scores. They get into other sort of fluency type things related to like, can you connect this concept to other related concepts? So things like list objects that are all the same color, or list words that all start with the same letter. Those, again, we see that women perform better than men. And then for men performing better than women, for spatial tasks, men perform really well on things like these object rotation tasks. They also do a lot better on manipulation of object tasks. So if you had something like, which of these would fit into this gap, they'd be a lot faster or more accurate at those tasks. And when we look at things like throwing or intercepting projectiles, males tend to perform better on those as well. I'm also noticing, talking about this, and you might have noticed this as well, switching between sort of men and women versus males and females. And it's my working with chickadees rather than humans bleeding through. So just in case you're wondering why I keep switching, it's not intentional. It's that I don't do research with humans, and therefore I default to male and female. So yeah, hopefully it's not bothering anyone. And in case you were curious, that's why. Every once in a while, I catch myself doing something odd because I don't do human research. But yeah, so that's some of the logic there. For this accuracy with aiming, there are more recent studies that look at things like ability and accuracy in things like first-person shooting games, where they see that males tend to be more accurate than females. But we then might look at something like, is that experience-based? Because if you look at the demographics of who tends to play those games, more males will play versus females. So is it mainly that in a general population, you're more likely to have people who have played games like that in the male group? Or is it actually related to something sex-linked? You'd have to double check types of samples that they took to get that information. But yeah, just again, pointing out, as always, some critical thinking in the background. While we're also looking at sex differences and other weird stuff that might be related, I figured I'd mention very briefly stereotype bias, or no, stereotype threat. That's the one I want. So this is a strange phenomenon where there are certain stereotypes, things like one group is better at this task than another. So if we're on sex differences, so one of the big studies will look at the theory or the stereotype that females perform worse on math tests than males do. And this isn't saying yay or nay for that task. It's very broad, because if we look at back here, so mathematical calculations favors females, whereas mathematical reasoning favors males. So it depends on what type of math. But if you have a group of male and females who are going in to write a test, and before the test, you remind them of the fact that some people think women won't do as well on the test, there ends up being sort of like a self-fulfilling prophecy where if you are reminded, you tend to match the behavior predicted by the stereotype. So women reminded that women score lower on math tests than men will then score lower than a control group where nothing was said to begin with. And this works for sort of different sexes, but it also works for, say, different cultures as well. So being aware of these stereotypes can actually get in people's heads and affect their performance. So it's a very, very neat area of research. So I thought I'd mention it here, even though it's not on the slides, but that is the stereotype threat. And for our last two slides here, I'm going to hop back and forth between these two here, but this is just looking at another different type of bias and some considerations within that. So we're going to look at outcome bias and predictive bias. But, oops, wrong way. But if we start with this diagram, I like the visuals. So if we're saying that an individual has some internal mental ability, this is their cognitive ability behind the scenes. We are going to then design a test that will give us some kind of score, maybe an IQ, that is going to try and quantify their existing mental ability. We might have a problem where there's a bias in our ability to quantify that true mental ability. So if we are underrepresenting or missing something of this individual's true mental ability using our particular measure, our score is then biased, and we would say that this is an outcome bias. So just with the words here, we're saying, okay, this is, if you quantify the strength of our bias, it refers to the extent that that test underestimates a person's true intellectual ability. I usually also point out that you would also, as a researcher, be concerned if you overestimate someone's true intellectual ability, but it usually ends up being a little bit more problematic if we frame these biases as a concern for, say, between group comparisons. And this outcome bias can be extra bad if one group is overly underestimated versus the other. So if we were comparing, say, North America to Europe, and it a little bit underestimates North American scores, but it a lot underestimates European scores, that difference in bias can be extra problematic, and it ties to stuff we've talked about already. But yeah, so outcome bias is just saying our score doesn't do a great job representing the actual existing mental ability that's inside somebody. Once we have that score, we might want to make use of it. So we could use this score to try and predict someone's performance in a particular area. So I've talked before about GREs being used to predict success in grad school. So our second type of bias is conveniently named predictive bias. And this is looking at whether there is some disconnect between this score leading us to an accurate prediction of how they will perform for whatever measure it is that we're concerned with. And if we go back to the slides, this is saying, does this test successfully predict some criterion measure, some idea of performance in that area of interest? So does it tell us if they'll do good at school? Will they do good at a job or whatever? And once again, here we're stressing that this can be extra problematic if the predictive bias is different between groups. So if it's not very biased, maybe it's accurate for North Americans with an American... sorry for the bird chitters there. They were doing so good and I'm almost done. Okay, hopefully. Last bit here. Yeah. So this can be really problematic if it's different between groups. So if we have a test designed in North America, the predictive abilities are really good in North America, but if they try and apply it in Europe and it does a terrible job there, then we would say that our predictive bias is unequal between those groups. And that, once again, can be problematic if it's accurate for one group and not another, because our interpretations of that can be then biased themselves. Okay, and that is the last thing I wanted to cover for this chapter. So I will leave you there with that.